let us start with the prayer. So let us start the program. First, we will have the space educational tour, followed by our, like wellness program. I invite Mr. Abdullah Sheikh to start. Sir, please. Please make Mr. Abdullah Sheikh co-host and he can start.
Good evening. Thank you, sir. Thank you for the warm welcome. Good evening, everyone. So today I'm here to discuss a very interesting topic. Right? Whenever we are learning about the space, we are always very curious and we are always very keen to know more and more things about the space. Right? So we'll keep this program. We'll keep this topic very informal, so we can have a lot of interactions. We can always have some questions coming in from all of our participants. So we'll keep it very open for all the questions. Either it can be by unmuting or questions can be sent in the chat box as well. I'll pick it up from there and I'll try to answer as many questions as possible. So with that, let us start. We'll start with a small presentation. As our topic today is astronomy, right? So when we are talking about astronomy, it's basically the study of space and the celestial objects, right? So we can have a little bit of reactions as well. Whenever you want to say yes, you can show me a thumbs up or give the virtual thumbs up reaction.
It's there, it's there.
Now, when we are studying astronomy or when we want to study astronomy, we need to have a few things, right? Like, for example, whenever we are doing any study or any research or experimentation or reference work, we always use a few different resources. So when we want to study astronomy, those resources are very simple, very easy, nothing that we have to go out and procure. Firstly, we need to have good eyes for exploration. That means observation. The observation skill can be very helpful. Secondly, we should have interest in curiosity. Study of space and space science is completely curiosity driven. We always come up with some questions. We always are very curious, and with that, we always try to find more and more answers, and we go deeper into the study. And thirdly, the next thing that we can use are the gadgets that we use on a daily basis, like our computers and mobile phones. But the question comes, how can we use these gadgets? How can we use the computers and mobile phones when we are doing our study? So today, I'll show you a very simple tool, a very simple digital tool or a software that can be used. There is an app that we all can download in our mobile phones, or we can access it through our computers or desktop. It is called as Stellarium. So right now I'm sharing that app on screen. I hope it is visible to all. When I open this app, I have a beautiful view of our night sky, right? We can see many stars. We can see a few planets, and obviously our moon, which is shining very bright. Now, when we try to do observations with the help of this app, the observations are very easy. We just have to zoom in. Like, for example, we have the moon, which is in full moon stage. So I just need to zoom in to whichever object I want to see. So like, for example, moon. Wow. When we zoom in towards the moon, we have the beautiful surface of the moon visible. And as we can see by the shape, it is in the full moon stage. If I just leave the screen as it is, you'll be able to observe that you'll notice that the screen is moving slowly, or the moon or the sky is moving slowly. Can anybody tell me why this is happening, why this movement is happening? why the screen is moving, if you are able to notice. Anyone? Check the chat box as well. The earth is moving. Very good, Tara. So when we look at the movements, right, in our solar system, in the center we have the sun, and around the sun we have all the planets revolving, right? But when we talk about earth not only revolves around the sun, it always revolves around itself as well, around its own axis. That is what we are studying since very small, since we were very small. So when earth is moving around itself, we tend to see the sky to be moving. So actually all these stars that we have, they are not moving, they are stationary, but because of the earth's revolution around its own axis, we tend to notice that the sky is moving a lot of times. So right now, let me go on to the real time. We were getting to see the night sky view, or the sky at 8 p.m. Right now, I have turned it to the real time. So this is the time right now, 17:07. And obviously, because we are reaching towards the evening time, but still the sun is still out there. So we don't get to see the planets and the stars very clearly. But with the help of the app, you can click on the small button down here, atmosphere. Now, what this button does is removes the atmosphere layer virtually, so that we can have a better observation. And right now, if I see, I have sun over here in this direction near west, because it is sunset time. Nearby, we have the planet Mercury. If I zoom in, we may be able to see the surface. Yeah, this is how the Mercury surface looks like, the smallest planet of our solar system. Similarly, let us try to find out some other planets as well. Like we have Uranus over here. This is how Uranus surface looks like. Now, all these observations that we are doing, these are virtual observations. If you go out with a real telescope and if you look in all these directions, these are the objects that you will get to see in real time as well. So these are real time movements of all these celestial objects that we are able to get to see. Apart from all these stars and apart from all these planets, we can also observe something called as constellations. Can anyone tell me what are constellations? Anyone in the chat box as well? It's okay if the answers come in the chat box. We can interact a little bit. Group of stars, correct. So what we have done is, there in the sky, if you look at the stars, sometimes they create a pattern. So those patterns of stars or those collections of stars, we have named them as constellations. So initially in Greek mythology or in Greek culture, they used to have huge importance. Even in our Indian culture, we know 12 constellations worldwide. Even worldwide, those 12 constellations are quite famous. What we know as the zodiac signs, right? So all these constellations, they are present in the sky at a specific time in a specific direction. The locations keep on changing depending on the Earth's revolution and the movement. But if you want to observe these constellations with the help of the app, you just have to click on the small button, and it will connect those stars together with the help of this imaginary line, and we'll be able to have a better look and a better view of all these constellations. Like for example, we have Pisces over here, we have Ursa Minor and Ursa Major, quite famous ones. We have the Orion constellation over here, one of the most famous constellations that we all know. So this way, with the help of this app, we all can have a beautiful observation of our night sky, even without a telescope. Even if you do not have a telescope available with us, with the help of this app, we can do this observation. So it can be accessed through your computers, your laptops, or in your mobile app. In your mobile, you can download this app. So I hope we are clear till this point. If any doubts, any questions, please feel free to ask. Okay, I assume there are no questions. So with that, we'll move forward with our
share this in the chat box. If any question is there, please share in the chat box. Please proceed,
yes,
sir.
please. Thank you, sir. So apart from all these things that we have seen, the digital tool, the software, the curiosity, apart from that, what instrument can we use if we want to do observations? Can you tell me the name of the instrument that we use for space observations? or when we want to observe stars or planets. Telescope, right? But when we talk about the telescope, there are many different types, correct? Telescopes, observatory, depending on how big it is or what is the scale of the observation device. The smaller ones, the portable ones, we know them as telescopes. When we have huge mirrors arranged in a very big space, that is where we use them as observatories. Sometimes we can use a binocular when we want to see the moon, like especially if right now it's full moon. So with the help of binocular, we'll be able to see it very clearly. But when we want to observe the objects that are slightly more far away from the earth or slightly at a distance, or if they are very small, binocular is not that powerful to make us see those things. So in that case, we have to use a telescope. Now, when we see any telescope, if you just type telescope on Google, you will get hundreds and hundreds, thousands and millions of different pictures of different kinds of telescopes. But they come in three main categories. Okay, we have to understand three main categories depending on how they are working. So the first category is called as the refractor telescope. Second category is called as the reflector telescope. And third category is the Cassegrain telescope. Now in school, we always study the refraction and reflection of light. You all would have studied. So when we talk about refraction, we are talking about the bending of the light. Like if I'm right now I'm wearing a glasses, right? So these glasses, they are lenses. So when the light will fall, it will bend, the direction of that light will change, and then it will go inside my eyes so that I can see properly, and the correction is there. So similarly, in a refractor telescope, there are lenses inside. Those lenses helps in bending the light, and multiple such bendings, when the light at the end reaches towards the eyepiece, we get a slightly better and enlarged image. So that's how the refractor telescope works on the refraction of light principle. When we have a reflector telescope, in reflector telescope, mirror is an example. When we stand in front of a mirror, the light reflects back, it bounces back to the same medium. And because of that reflection, when it happens inside this small cylinder, there will be a reflector, there will be a mirror at the back of the telescope, and there will be a flat mirror on the front of the telescope. So when the light will fall in onto that mirror, it will bounce back, it will again reach another mirror, and then it will reach towards the eyepiece from where we can do the observations. And for these reasons, because of these bending and because of these bouncing backs of the light, the images that we get, they get enlarged and we get a beautiful view. The third category is the Cassegrain telescope, which is the combination of the first two types. For example, if I take the lenses and the mirrors both, and if I combine them in a way that I get a very high resolution images, that is how we design the Cassegrain telescope. So refractor, we can call it as a low power telescope. Reflector, we can call it as a medium power telescope. And Cassegrain, we can call it as a high power telescope. Depending on what extent of our observations are or what kind of observations we want to do, we can use these three different kinds. Okay. Here, three different types of telescopes. Now, apart from these types of telescopes that we personally can use, we have some very, very high resolution telescopes, what we know as observatories. Again, they are also based upon the reflection principle. Huge mirrors are used over there as well. But there are some telescopes that we have sent in space. We call them as space telescope. The first such space telescope was launched in the year 1990. It is known as the Hubble Space Telescope, as big as the size of a school bus. So we all can have a small comparison of how big this telescope is. And since past 30, 31 years, it's still operational, it's still working, and clicking picture, it can do infrared observations, it can take X-rays, and it can send the data back to the Earth. This was the first space telescope, the Hubble. Any doubts, any questions till this point? Anyone want to ask any questions? You can put it in the chat box. Okay, great. So apart from the telescopes and the observation devices, we have another very interesting thing sent in space. Have you heard of International Space Station or ISS sent by NASA?
Yes, yes.
Great. So why we call it as an international space station? Because it is an international project. It's not only NASA that has designed the space telescope, the ISS, and has sent it there. So 15 countries have collaborated together with their space agencies, and together it was built in the year 2000, where it's like a huge research lab that has been set up in space, where astronauts can travel, they can live there, they can do some research, they can do some studies, and once their tenure is done, they can come back to the Earth. So like that, every 6 months, a new batch of astronauts go there on the International Space Station so that they can have the observations. So right now, we'll try to connect with the International Space Station so that we can see how the Earth looks from space. Okay, here we go. We can see the beautiful view of Earth. Some of the solar panels can be seen. Some more of the instrument like these docking devices, the Canadian arm, which helps the astronauts to travel and navigate through the different places when they are working. And an astronaut is also out there. Can you see the astronaut?
Yeah.
It's quite a rare view. It's not very often they come out. Whenever they want to do some repair, some upgrade, or some maintenance work, they wear their spacesuit, they come out of the space station with the help of some robotic arms and anchoring devices. They reach to that specific place where they want to work. They complete their work. It takes about 6 to 8 hours depending on the extent, and they after that they go back inside. In the background, you can see the space, dark black, pitch black. And wow, right now we have connected with the helmet camera, so we can see the actual point of view of the astronaut. It's quite a beautiful view from up there. If you look at the Earth, you can see the clouds, a little bit of ground if you can make up by the color, the dark brown, the green color, the bluish color that you see, that those are the oceans. So the space station, it's not actually stationed at a place. It's constantly revolving around the Earth at a very high speed. The speed is about 25,000 kilometers per hour. So it's so quick, it travels at such high speed that it takes only 90 minutes, only 1.5 hours to complete one circle or one revolution around the Earth. That's how quick the space station moves around the Earth. It's as big as the size of a football field. So as I said, currently there are 7 astronauts, out of which one of the astronauts we can see how he's working outside. I hope you all are enjoying the view.
Yeah.
So that was the space station. So that was how the astronauts are when they are outside the space station. Whenever they are outside the space station, they have to, wear the complete spacesuit, which will protect them from the sun rays, the intense sun rays that are coming in, the pressure and the vacuum that is there, when we are in space. So it will protect the astronaut from all those things. But when they are inside, they don't need to wear all those things, the spacesuit and all. So when astronauts are inside the space station, let's see how they will live inside the space station. Here we go. First thing that we are looking at is how do astronauts brush their teeth. It's very famous. I'm sure you may have come across this one. This is how space station looks like if we see from a faraway distance.
I'm just joking. It still stands up straight. It doesn't matter
Very famous
where you
astronaut,
are. It's always going to stand up straight while you're up in space.
traveling and
A lot of people ask about toothbrush and toothpaste. So, luckily enough, toothpaste, you can do it upside right this way, is sticky, and so it sticks to your toothbrush. No problem. Another cool thing is that water sticks to your toothbrush too.
So when we are in space,
see it. I'll have some water come out.
Because of very low gravity
water
or
is
weak
pretty
gravity,
neat up in space.
all these objects will
stick to your toothbrush
to float.
And it will make.
So technically they are not completely in outer space. They still fall into the Earth's gravitational force, but they are constantly moving around the Earth, what we call as inertia. And because of that inertia, they always tend to have this floating effect. That's how they drink water when they are in space.
So a lot of people ask about what do you do
isn't it?
with the toothpaste after you brush your teeth.
after brushing the teeth. Now, when we are on Earth, we have ample of water. We gargle, we wash our mouth, and we also, use a lot of water. But they don't have
Two
that
options.
much water.
Swallow it, and it's sort of like mouthwash.
So once they are done brushing,
tastes a little
they have to
gross.
swallow the toothpaste, or they can spit it in a
Or-
paper towel.
You can just spit it out in a paper towel, and then you don't have to worry about it. Swallowing thing I wouldn't recommend at home. I'm only up here for 4 months, so it's not that bad.
So that's how when the astronauts are living in the space station, when they are living inside, most of the time they are floating, and all the work that they will be doing, similarly, they have to be working with that floating effect itself. So before they actually went on to the space station, they have to take their training. They have to train themselves to work in, living in the space station or living in zero gravity. Which app? We have got a question. Which app? The name of the app is Stellarium. I've sent it in the chat box. And there is one more app that can be explored by the participants. It's called as Star Walkthrough. These are the two apps that I would recommend you using. They are very beautiful, and we can have some amazing observations with the help of both the apps. Moving forward, we have seen how astronauts brush their teeth in space. Let's see how will they cook their food. Now, most of the time they do have their dehydrated food. Their food is in the form of a dehydrated form, like vegetables and fruits and all those things. It's in the form of dehydrated thing. They have to rehydrate it. They have to add water, and then they'll be able to eat that vegetable or a fruit in order to preserve the food for a longer period of time. So that's why the foods are dehydrated, but sometimes they even like to cook a few different things. So in order to cook those things, how will they prepare? Let's take a look at that.
Hello, I'm ESA astronaut Samantha Cristoforetti. Welcome to Node 1, the place where we prepare our meals and eat up here on the International Space Station. I would like to show you one of my favorite meals up here, which is a chicken turmeric with champignon mushrooms, brown rice, and peas. And I would like to try and put the ingredients together for you, see how it works in space. Well, first of all, we don't have a plate. It wouldn't make much sense. So I'm gonna try and use a tortilla instead of a plate. We have plenty of those. They're kind of handy up here because they don't make crumbles, which are a little bit of a problem. And then I want to make sure that the ingredients stick to the tortilla. So I'm gonna start by spreading some peas cream. I have already heated the food pouches with the ingredients in the food warmer. So this is my first ingredient, peas. And this is one of the most important tools up here in space when it comes to the kitchen, a scissor to open the food pouch. So I'm gonna spread it on the tortilla. It's kind of hot. Okay, next I will add brown rice. It's whole rice, it's not refined, so a great source of good carbs. Next I will add some champignon mushrooms. And finally, my chicken with turmeric. There we go.
Along with all the ingredients is always floating. Again, the inertia concept. Now, when all these ingredients are being used, they are in the form of a paste. Because if we use the ingredients as it is, as we use on Earth, it wouldn't make any sense. If, for example, if we are taking green peas, so all those tiny bits and the grains of peas will keep on floating everywhere, and she'll have to spend the rest of the day collecting all those things. Again, same case with the brown rice. Brown rice grains are even smaller. So using the grains as it is not possible for them and not practical for them. So they tend to make it into a paste. They apply these paste together depending on the recipe and how they want to enjoy it. And then it's like a big khichdi, like how we eat khichdi in India. It's kind of like that with all the different ingredients. They will be able to enjoy the flavors, but there won't be any feeling of any texture. So this is how the astronauts, they prepare some of their favorite meals when they want to try something new or when they want to try something different, other than some of their the dehydrated food or some energy bars or protein bars and all those different things. Any doubts, any questions till this point?
No, I don't know.
Okay.
Please proceed.
So many times I get a question like, how do astronauts sleep? Right? So sleeping is something very interesting for them. When we are in space, we don't have a feeling of lying down. Right? We cannot feel lying down on the bed, which is kind of the best feeling after a tiring day of work. So when we are in space, we don't have that feeling. They just have to go inside the sleeping bag, which is usually tied inside a small cabin, or with the help of a cable, it will be attached to the side of a wall or any side of the cabin. They just have to go inside that and close their eyes and fall asleep. That's how they just go to sleep. For whenever they want to take a bath, when they want to clean themselves, they use waterless shampoos, waterless soaps, or they use sanitization chambers that nowadays we are quite aware of those chambers. There is a sanitizer liquid that will clean off all the germs and all the bacteria. That's how they tend to manage living in those kind of situations as well. With that, we move forward towards our presentation and we'll take a look at our solar system, the planets that we have in our solar system. What about hair? Sindhu is asking, what about hair? So for the hair, they, as I said, they have waterless shampoos. Like how we pour some sanitizer on our hands and we just rub it off and it goes off, and the germs are also killed. Same way, they for cleaning their hairs, they use waterless shampoo. They just put it on the hair, they wash it, they rub it, and then they clean it with a towel or with a paper towel, and it's all clean. And when we are in space, it's very unlikely for the microorganisms to grow also, because there is no air. So that is why it's not that of a big issue. Continue with our solar system. This is how our Milky Way, our galaxy looks like. If we travel billions of light years away, that means if we travel at the speed of light for about a few billion years, that is when we go far enough to see our whole Milky Way collectively together, which is like a huge collection of many stars and many solar systems, in which our solar system is a very teeny tiny part. It's like a very small dot we'll be able to spot over here. So let's take a look how our solar system look like, and how are we dividing our planets. What are the different planets that we have, and how do we divide them in order to study them better?
The solar system is located in the Milky Way's Orion star cluster. Only 15% of stars in the galaxy host planetary systems, and one of those stars is our own sun. Revolving around the sun are 8 planets. The planets are divided into 2 categories based on their composition: terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid, they don't have ring systems, they have very few or no moons, and they are relatively small.
So basically the 8 planets that we know of, we have divided them into 2 different categories. First category, we call it as the terrestrial planets, and the second category is the Jovian planets. In terrestrial planets, we have all those 4 planets which are on the inner side of the solar system before the asteroid belt. All these 4 planets, they are made up of solid and rocky material. They are quite smaller in size. They may have 1 or 2 moons, or they don't have any moon at all, and they do not have any rings, unlike the other 4 planets who are on the outer side of the solar system, beyond the asteroid belt. All of them are very big in between the terrestrial planet and the Jovian planets. It is kind of like divided with the help of these asteroid belts. Now, these are the 8 primary planets that we all know of. Apart from these eight primary planets, we also have 5 dwarf planets. The planets which are quite smaller in size, who have quite a weaker gravity compared to all the primary planets. We very famously know Pluto, which is a part of the dwarf planet category. We also have Makemake, Haumea, Ceres, and Aries. These are the 5 dwarf planets that we have. We have a question. What about the wastage? How do they manage garbage? So majority of the garbage is many times stored within the chambers, within the containers that they have for the waste disposal. But the excreta that is there when they are using the bathroom, that excreta, it is just thrown off in space. That's a part of the space pollution or the waste that goes off into the space. This was about the solar system. Now, we always are very curious on how this universe was created, like the planets and how the sun, the stars, and each and everything that we have in our solar system. We always try to figure out one theory that explains this formation of universe quite in very detailed manner, and also with a lot of detailed explanations. That is why this particular theory is quite worldwide accepted. It is called as the Big Bang. Yes, correct. So we have a beautiful documentary that explains us, gives us a virtual perspective of how these events could have been taken place and how the universe would have been formed. So let's take a look and enjoy this beautiful view.
What if we could tell you everything? The entire history of the world. We're going to tell the whole story. This is our infant universe. Everything that will ever exist, everything that will ever happen, all begins here, within this tiny bundle of energy, smaller than an atom. And right now, history as we know it is about to mysteriously begin. For reasons we may never know, our universe suddenly erupts. Within a fraction of a second, the Big Bang creates all the energy that will ever exist. All the energy that will power the stars, that will fuel anything that ever lives. All the energy that you will ever consume dates back to the beginning of time. 300 million years after the Big Bang, inside of forming galaxies, gravity continues to squeeze together clouds of gas and dust, causing pressure and heat to violently rise. When the temperature reaches 18 million degrees Fahrenheit, hydrogen atoms slam together, creating a new element, helium, and radiating bursts of energy. The first stars are born. But something is missing from this early universe. There are billions of stars, yet not a single planet. These explosions, known as supernovas, are the biggest blasts in the universe since the Big Bang, providing the extra boost of energy needed to fuse heavier elements. Stars explode and are reborn. Each generation with more heavy elements than the last. Until 4.6 billion years ago. Finally, there are enough materials gathered for the next step on the path to us. A new star is born. This is our sun. It's so massive that it's gathered up 99.9% of the gas and dust in the solar system. But there's still just enough left behind for gravity to build some other things. Like planets. The third one out from this star will be our home.
Now this is where we have reached to the point where our solar system is going to be created. The sun has already formed, the planets have already formed, but they are all in the form of a huge ball of molten lava. But 4.5 billion years back is when we believe our Earth was formed and came out of the debris from the sun. And that is when 4.5 billion years ago also is the time where our moon was formed.
4.5 billion years ago, an object the size of Mars smashes into the planet at 25,000 miles per hour. Earth swallows up much of the impactor. But a spray of molten debris is whipped off into space. Within as little as a year, gravity gathers this debris into a secondary sphere in orbit around the Earth, where it has been ever since.
So this is how the explanations of the Big Bang Theory has been virtualized into this beautiful documentary where we can understand and we can have a look. But still, it is still a theory. It's not that it is 100% true. There's something that we have came up with the evidences, with the theories and the discoveries that we have had, collating all the information and the data that we had, and all the knowledge and understanding of the space and our planet, of the other planets that we have. Whatever we collected with that, with the help of that, we have created this theory that we may have these events occurring at that point of time, because we were not there 13.7 billion years back, not even 4.5 billion years back. But recently we have got a few discoveries or some developments with the help of which we are expecting to see things in the past. Like you would have heard of James Webb Telescope. It is known to be the biggest and the most powerful telescope ever made. The James Webb Telescope is designed in a way that it will help us see the light that has started to travel 13.7 billion years back. So if it is able to capture that light, we may be able to get the pictures just after the Big Bang had occurred. So it's still in progress. The James Webb Telescope has already been launched. Once it settles down, once it takes its position, once it starts taking the observations, after that we'll be able to come to know what are the observations we are getting from there. So that was the Big Bang theory. Any doubts, any questions till this point? Any participant? Okay. So before we go ahead, we'll take another look.
Yeah.
At the Stellarium app, as we have observed a few different things. Okay, we can see some participants have joined recently. So I'll quickly give a view of the Stellarium app. So right now, this is the real-time observation, the real-time positioning of the stars and the planets, some of the stars and the planets that we can see from Earth. And this is a location geotag software. So whenever you open the software, I am sitting in Mumbai, so it's captured my location and it is showing me what are things that I can see from Mumbai. Whichever state or whichever part of the country or whichever part of the world you are, you'll be able to pinpoint your location and you will see the observations that are present in the sky. Also, if you download the mobile version, on that, there's a feature where you can turn on the camera. You can point your camera of your mobile phone towards the sky and it will show you what all things are there actually in that patch of the sky that you are able to see on the screen through the camera. So that is also another feature. Over here, we have this constellation called as Orion. You may or may not have heard about this constellation. It's very famous and quite easy to identify. If you have a clear night sky, it's quite easy to identify, quite easy to find out this particular constellation. If you find 3 stars very close to each other, kind of like in a series. That is how we try to start identifying this particular constellation. We look at these three stars first, then we look at the shoulders, the arm, then the hand. This is the shield, this is the weapon. So Orion was the name of a Greek hunter. It was known to be the greatest hunter in Greek mythology, and after him this particular constellation was given the name. You can see a satellite also moving very quickly from this particular direction. If you click on it, you'll get more information. This is a Starlink satellite. It belongs to Elon Musk's company, SpaceX. Apart from the constellation, if I zoom in towards the star, can you tell me what is the color of the star? The name is Betelgeuse, right? You have to tell me the color. What's the color of the star? Come on. Golden, right? Or we can say orange or yellow, right? So in case of stars, the spectrum of color starts from blue till red. So whatever colors can be formed from blue, light blue, white, it will go towards yellow, orange, and red. Okay, and that color will actually tell us what kind of temperature or what kind of behavior that star or what kind of energy the star is having. Yes, white also. So here is an example of orange color. Let's see another example of Bellatrix. Let's see the star. This is whitish to bluish in color, right? So you have to tell me which star is hot and which star is cold. We have the names. You have to tell me Bellatrix if it is hot or cold. Betelgeuse, is it hot or cold? Come on. I'll again send the name of the app, Stellarium, or you can go on the website, stellarium-web.watch. Yes, tell me which one is hot, which star out of these two is hot and which one is cold. Just look at the color and take a guess. Let's say first Betelgeuse. Tell me, is Betelgeuse hot or cold? This one, Taran says Betelgeuse is hot. Soumya says cold. He says hot. So this star is hot or cold? We are getting some mixed answers. I think I'll have to do voting. This is hot. So normally if we compare with sun, okay, we see that the sun is very bright, reddish in color, so it must be hot, right? But actually, this color tells us about the energy that a particular star will have. So if you see a star with blue to white color, that star is very high in energy and it will be very hot in temperature. If you see a star with red color, that means it has lost majority of its energy and it is cooling down. So this particular star, Betelgeuse, is a dying star. It is losing its energy, and in about next few million or billion years, it may explode and die. So when you see yellow, orange, or red color, that means it is a dying star. It is losing its energy and it is cold. But if we see a whiter or a bluish color, it's more hot, it's more energetic, and it's a new one. It's a freshly made star also, if it is very white and very blue. Now you'll say, okay, sir, sun is yellow in color, it is so hot. So sun falls in between the intermediate section, right? The yellow color is somewhere in between. It comes in the middle of red and white or blue. So it forms in the intermediate value. So it has already, spent half of its life, lost half of its energy, but still the half of the energy that is there, from that the energy and heat that is coming in, that is what we are experiencing on our planet, right? So it's reached halfway. When these stars are born or when these stars die, it happens, it's within a place called as nebula. Let me see if we can see any nebula over here nearby. Orion, not only a constellation, Orion is a nebula as well. So if you see a cloudy thing over here, the yellowish, orangish cloudy thing that we see, this is nothing but a nebula. It's nothing but a cloud of dust and gas. But within a nebula, new stars are born. Now, when old stars die, a lot of energy comes out. A lot of energy is, is released. And energy cannot die. Energy can only be transferred, right? So that energy, when it is transferring within a nebula, that helps and that results in the formation of a new star. And that's why nebulas are known to be star nurseries, the places where new stars are born. And with the help of NASA, we are going to take a look at, yes, that explosion is called as a supernova, a very high energy explosion. So with the help of the images that we have got, with the help of Hubble Space Telescope, with the help of Goddard Space Telescope, and all the other and the Spitzer Space Telescope, with the help of those telescopes, whatever pictures we have got, we have collected all those images, and we have created a beautiful, walkthrough, kind of like a 3D effect. It's like watching a 3D movie. So we can see how a nebula would look like if we go inside it. Trillions of stars are present not only in our galaxy, within the nebula as well. So this is the Orion Nebula, the closest one to our solar system. The stars, the cloud looks very colorful because of the different kinds of gases that are constantly being released and formed. So it actually looks this colorful if we see from the telescope. So today we have tried to discuss of some very important or some very interesting concepts of astronomy, like the telescopes, some software that we can use, the Big Bang theory, the constellations, nebulas. And before we end, I'll also touch some on a very hot and very interesting topic nowadays of black holes. So it's a very complicated science behind black holes. We have very limited knowledge about the black holes, but how or what are the concept, what is the reason behind the black holes? Let's try to understand that.
Black holes are the most powerful things in the universe, strong enough to rip whole stars into atom-sized pieces. While this is scary enough, they have an even more powerful and dark property: they might delete the universe itself.
Just try and reshare it. Sorry, I'll restart the video. So in simple terms, if we want to understand a black hole, we can take an example of a vacuum machine. Okay, if we see a vacuum cleaner, the concept is, with the help of vacuum, it pulls in, it sucks in all the objects or any part or any particles of dust very quickly, and because of that sucking part, everything gets collected within the cleaner, right? But when we have a black hole, we can imagine a black hole to be billion time or trillion time more a more powerful vacuum cleaner. But in this case, when the vacuum cleaner is pulling the things inside, it's not small particles of dust. It can be stars, it can be planets, and it can be anything around the space. And when it is pulling it inside, it's not just taking the thing as it is ripping it apart into small atom-sized pieces so that it cannot be formed again, or it's very difficult for that object to form again. So that's how this particular concept of black holes, came up with the help of Einstein's theory of relativity. But Einstein was not able to prove that black holes are real. So what do you think? Are black holes real? Yes, correct. So in 2009, not very far back, just in 2009, we confirmed the existence of black holes. We were able to click pictures of a black hole. Now, is it possible to see a black hole? Yes, no, maybe. It sucks light too, so we can't see it, see a black hole, right? But when I say we clicked a picture, it's a picture where black hole is like a huge sphere of blackness. We can't see or how it actually looks like, because it will pull in all the energy, pull in all the light itself too. But the objects that are present around it, okay, around the boundary, or what we call as the event horizon, we look at the behavior of all those objects, like is there any disturbances, is there any energy change of all those objects, and with the help of that, the astronomers came up with the existence, and came up with the actual positioning of the black hole.
Black holes are the most powerful things in the universe, strong enough to rip whole stars into atom-sized pieces. While this is scary enough, they have an even more powerful and dark property: they might delete the universe itself. Black holes in a nutshell. A black hole appears when an extraordinary amount of matter is concentrated in a tiny space. At their center, gravity is almost infinitely strong, and whatever gets too close is ripped into its elementary particles. Not even light can escape black holes, and so we perceive them as spheres of blackness. If you were to fall into a black hole, nothing bad would happen until well after you crossed its outer border, the event horizon. You can imagine this as swimming in a river that ends in an enormous waterfall. As you float along, imperceptibly, the stream gets faster and faster, even if you can't see the waterfall yet. You could swim to safety until, without even noticing it, you cross the point of no return. No matter how fast you try to swim now, the stream will pull you towards certain death. Nothing can escape a black hole waterfall once it gets too close. This border completely separates black holes from the rest of the universe. We can't access them unless we're willing to never return. So there's no way of telling.
So we can see a black hole only once in our life. After that, will not exist. And that is the main reason why we do not have much information about a black hole. We can't send anything close to a black hole. We can't send any device. We can't send any human over there. And that's why we are just, right now relying on to the physics and are relying on the maths that was given out by the Einstein's theory of relativity. And there is another concept related to the black hole, which is known as wormhole, which is known to be the opposite of black hole, or the white holes, from where the debris that has been taken in by a black hole, it will pass through a wormhole and it will reach and it will open onto the other side, other end. But white holes do not exist as of now. We don't have any of knowledge. But the black holes, yes, we have confirmed the existence of black hole, and we believe that at the center of almost every galaxy, we have a huge black hole that, over a period of time, will engulf the whole solar system itself. So there are chances, if the black hole that we have spotted, if it comes quite close to our solar system can also vanish inside that black hole. So with that, I rest my presentation. I hope you all have enjoyed the session on astronomy. If there are any doubts, any questions, please feel free. Thank you everyone for joining in today with us.
Yeah, I have a question. Beautiful
Yes.
presentation, sir, because we can't see all these things live. So you have taken us through a virtual tour, and it was awesome. What I want to know is, can we paint in space?
Can we paint in space? So if we I mean to say, when we actually go there and with our paint and paintbrush, that way. So if we have a device, where we can actually contain the vacuum, because in space there is a lot of vacuum, there is a lot of pressure, so we will be able to have it. But when we use our brush, or when we use the water, when we use the canvas, when we use the paint, it will be very tricky, very difficult to manage, because when we take our watercolor, it will not stay on the brush. It can form small small droplets, and it will keep on floating everywhere. Water and paint, they have a tendency of surface tension, so they will quickly combine. Because of that pressure, the pressure will not match, and because of that, it will be very difficult to paint onto the canvas, transfer the paint with the help of the brush, or other anything, the brush. But yes, if we design something that can sustain in that pressure, that can stick onto the canvas at that time, maybe. But we haven't tried any such thing yet.
So we can spend some more. Any more questions? You can please the chat box, or you can just write. You can confirm, ma'am, co-host. Sorry, ma'am, and confirm, ma'am. Any other doubts? You can actually, yeah, there are certain things in the chat box. Yeah, very interesting topic. Any questions? You can just type it. There will be. Or shall we move to the next segment?
Thank you, sir. Thank you, everyone. It was a great pleasure conducting the program.
Step back, Mr. Abdullah Sheikh.
Sure, sir. Yes,
There
yes,
is one portion to complete.
no worries,
That
no worries.
Soumya ma'am said that is about, wellness.
Sure,
Soumya
sir.
ma'am,
I'll be there in the background.
yeah.
Thank
Soumya
you.
ma'am,
Over to you, sir.
yeah, thank you, thank you. Soumya ma'am.
Yes, hello everybody. So today, because we came to know a lot of things about the space, I want all of you to hold the thought, because we're going to do something with space. That's what particularly I asked the question, can we paint in space? So hold on to the thought, hold on to what Sir has actually told us, because we are going to do something with that thought in our mind. So come on, let's switch on our videos. We are going to do, we're going to start straight away to a session. We're going to start with the massage, because we have been we have been sitting, we have been listening, and all through the week we would have been working. So let's relax ourselves with some massage. So with your palm, you can sit, palm and your fingers, just start massaging. Am I audible, sir?
Yes, ma'am, yes, ma'am, yes, ma'am. Yes, ma'am.
Yeah. So please start massaging your scalp with your fingers, all the tips of the fingers and your palm. Slowly, you can even close your eyes. Just feel what the touch, because you don't have to look on the screen. Just give some eyes rest. You can very well follow my instructions. Just rotate, just massage. Close your eyes. You will get some rest also to your eyes. Now, with one hand and the palm, just massage the center of the head. Center. massage the center, the crown chakra. Around that, just massage. Then take with both your hands back, massage the back of the head, nicely massage. Feel the pressure. Feel what it does when your fingers touch your scalp. Massage it well. Then nicely rub your palms. Rub. We are coming to our face. When the palms are really hot, just do a massage all over the face with your fingers. Massage your face. Now take the thumb and the pointy finger, keep it just up and below and above the eyebrows. Just press it. Press and pull. So you'll feel a lot relaxed when you do it around your eyes and your eyebrows, this portion. Press it and pull it. Now take your pointy finger and your middle finger. You can feel the bones around your eyes. Press it and take it around the eyes. This is so good for relaxation of your eyes. When you are in front of a gadget or when you are in front of TV for 1 hour, 2 hours, just do this. You will really feel much relaxed. Press it well and go for an anti-clockwise. You can feel the bones, so press it around the bone, zygomatic and the bone here. Now, again with the 2 fingers, just pull it below. We pressed the bone, right? The same bone, just pull it as if you're pulling it apart. Now open your mouth and keep your skin firm. And with your fingers, you're pressing it till the jaw, giving a massage to this portion. This skin should be stiff for that. Now nicely rub again. Keep your left finger on top of the left eyes and the other, and just close your eyes. This is called eye palming. Now let's do a bit of warm-ups. Head rotation first. Just start rotating your head. 2, 3, opposite. 1. You can do it slowly, no hurry. 2, 3. Shrug your shoulders. All your shoulder tension would just get released. Shrug it down. Shrug down, shrug, down. Now let's stand up. Come on, stand up with me. Keep your one leg in front. Keep your one leg, just keep your right leg in front, and let's give some exercise to our hands, arms. Like swimming. How do you do swimming? The same way, your fingers closed like this. Move it. 1, 2, 3, 4, and 5. Now opposite. 1, 2, 3, 4, and 5. Now we are going to do some wrist rotation. Okay, for us, we don't lift our hands much. So let's lift our hands and do the wrist rotation. Rotation, clockwise and anti-clockwise. Then rotate your arms. Rotate it the other way. Don't stop doing it. We are adding one by one. We are not stopping the wrist rotation, but we are adding the arms rotation. Now move your hips along with it. Move your hips, rotate your hips. So your arms and your wrist and your waist, you're rotating all these parts. The other way, the other side. Rotate. Now along with this, I'll show you, we are going to rotate our knees. You can even keep it down if your hands are paining, or you can do it keeping your hands up. You can do it keeping your hands up and moving your arms, your wrist, your hip and your knees. Now let's just keep your feet apart, bend a little bit on the knees, as if we are pulling the rope. Swing your arms well. Let all the tension of your arms get released. Swing, swing, swing. You can even do some bouncing. Bounce, bounce. Yes, now stretch. Let's stretch our arms well. Stretch up, and you have to stretch up and stand on your toes. Stand on your toes, stretching your whole body up as if you're going to touch your sky. Come on, try touching your sky. Try touching the sky. Yes. Now on your heels. On your heels, on your toes. On your heels, on your toes. On your heels, on your toes. Once more, I'll show you that. See, I'm on my toes and on my heels. Toes and heels. Now, let's catch something moving our body. Twist the body. Imagine pulling something from here, from the shelf, moving our hands to the opposite. Now, keep your thumbs together and we are just twisting to the back. twist this side. Now let's do some wriggles. Jump, jump, little bit. Come on, come on. After stretches, let's just do some shaking out all the stress away, shaking out from our body, stress, anxiety, negativity, any toxic thought. Everything is going out of your body. Imagine something gray going out of your body as you move. Imagine. Yes. Okay, now I told you all to hold on to the thought. What Sir told. Like painting on the space. Imagine we are going to paint our own names on the space. Imagine the space around you is a space station, and you have canvas everywhere. You have canvas in front, you have a canvas on top, you have a canvas on the floor, this side, that side. Everywhere around you have you have plain canvas, and you have got paint. Even though the paint in the space goes like the bubbles, we can catch a bubble with our palm and paint. It's all in the imagination. So you can paint with your palm, you can paint with your elbow. You have to paint your own name everywhere around. Your own name in the space station, everywhere. On the walls, on the ceiling, on the sides. So you can paint even with your legs. Okay, imagine paint here. So you can paint with your legs. You can paint with your whole body moving. You can paint like this. You can paint with your palm, with your tummy, whatever you want. But you're painting your own name. You can paint in calligraphy, beautiful calligraphy. Those who know, so you're painting it so big. Okay, so you can paint any way you like. When I start the music, you are going to start painting. Come on, just give me a feedback if you can hear the music, okay? Is it audible?
No, ma'am.
Is the music heard?
No.
Is the music okay? 1 minute. It's not heard, sir?
No, ma'am.
Now? You can all take your seat. Just breathe. Take a deep breath. Breathe in and breathe out. Actually, I want you all to write down what you felt. You have your blessing note, right? Please write down your reflection. What did you feel when you were painting your name everywhere around? So that's what you have to write along with your blessings for today. It would be good if you write it immediately so that you still are experiencing that, your body still feel that movement, how it is when you paint your name around in your wall or in a space. So if we have really imagined as if we are in a space station and painting the space station and painting the space all around with our name, you can just see your name dazzling, with multicolors. You're throwing colors. So what you really felt, how you felt in your mind, how you felt in your body, please journal it. That would be so good, because whatever you feel, if you write it down, that is a way of expression. You can write it in any ways, but just even you can draw. Those are good at drawing, they can draw. If you feel anything else, if you want to write some poetry, you can do it. So whatever it is, note it down, write your blessings for today. Don't forget, every time I keep telling you. Now close your eyes. Look at your palm. My life is a precious blessing. My life is in my hands. I design a beautiful life for myself. I take responsibility for all my words and actions. I do not blame anyone for where I am in my life. Thank you. You're all amazing. So imagine you have the paintbrush and the paint of your own life, and paint your life with multicolors. Thank you so much.
Today we were in space for some time. Now we are on the earth dancing and painting. Excellent session, ma'am. Excellent session. So the time is almost up. Thank you, Soumya ma'am. Thank you. With a different topic.